Hi everyone, this is Fahad Mirza and I welcome you to the channel. It seems that now all the focus is on thinking models. It all started with Qian's QWQ and QVQ models in the open source when they showed lot of benchmarks beating the closed source OpenAI's O1 and Google's models. Both OpenAI's O1 model and Google's Gemini 2 Flash model have excelled in reasoning, which has proven to solve complex tasks by producing a long internal chain of thought. The technical details and model weights of these closed source models are unavailable and inaccessible, which is a barrier to the participation of the academic and open source communities. That is where these QWQ and QVQ shines through. We already have installed them locally and seen how good they are in terms of reasoning. That is why I was quite excited to see this new model Sky T1 32 billion, which is a fine-tuned version of QWQ model from Quen, which is also a 32 billion model. This model has emerged to beaten a lot of other open source and also closed source model on math and coding benchmarks. So if you're looking for an open source model for math and coding tasks, especially from the prism of thinking and reasoning, this could be a good choice. This reasoning model has been trained from Quen 2.5 32 billion instruct with 17,000 data. They have also shared a lot of benchmarking information on their model card, which you can check out, and I will drop the link in video's description. I'm not going to go into that detail, but just to give you an overview, they used this 17,000 data and they performed supervised fine tuning on the data with a batch size of 96. They used a Llama factory for training, and on 8 H100 cards, the training takes 19 hours with Deep Speed 03 offload. And the cool thing is that they only spent 450 US dollar to train this model. We are going to install it locally and then we will see how it performs. Especially I will be testing it out on math and coding problems, so let's try to get it installed and see how it works. Before that, let me give a huge shout out to Mast Compute who are sponsoring the VM and GPU for this video. If you are looking to rent a GPU on very affordable prices, I will drop the link to their website in video's description. Plus, I'm also going to give you a coupon code of 50% discount on range of GPUs, so do check them out. This is my Ubuntu system and this is my GPU card H100 with 80 GB of VRAM, and if you're installing this model in full, you would need at least that much VRAM, and I will also show you the real-time VRAM consumption as we proceed further. First up, let's create a virtual environment with Conda. And now let me install all the prerequisites, which include Torch and transformers. And now let me launch my Jupyter notebook. And now let's download the model after importing some of the libraries. And the model is being downloaded. You can see that there are 4 shards of it. So let's wait for it to get downloaded. And while it downloads, let me also walk you through some of the training processes which they have used, because that is quite interesting. And the main thing that they only utilized 450 US dollar to train this model is quite interesting. Really good stuff. Before that, let me also introduce you to the sponsors of the video, who are AgentBot. AgentBot lets you effortlessly deploy a personalized knowledge bot across platforms like Discord, Slack, and others. It is ideal for open source tech communities and startups that provide user support, and I will drop the link to their website in video's description. Coming back to this model's training, now they used QWQ 32 billion preview model for it to generate its training data. So the training data is all synthetic. They curated the data mixture to cover diverse domains that require reasoning and reject sampling procedure to improve the data quality. They then rewrote QWQ traces with GPT-4o mini into a well-formatted version to improve data quality and ease parsing. They also found out that the ease of parsing advantages for reasoning model They are trained to respond in a particular format where results are often hard to parse, and that is where once they got it right, the accuracy just went up. And that is one thing I was quite impressed about the training. And you can read the further detail in their model card, and I will drop the link in video's description. And it is taking a bit of a time today. As you can see, it has taken around 2 minutes for each shard. So thankfully it is now at the last shard. So it's been around, I would say, half an hour. It's being downloaded and everything, the things which I do for you guys. Anyway, let's wait for it to finish. Make sure that you have around 75 gigs space for this model to fully get downloaded on your system. Shouldn't take too long now. So the model is downloaded, fully loaded onto our GPU too. Let's do the inference. For the inference, what I'm going to do, I'm just going to use the usual Qwen prompting. So this is where I'm giving it the prompt where we are asking it to do a reasoning and on a math equation. This is a typical QWQ prompt which really shows you how it goes step by step thinking. And then it's a usual prompt template where tokenizer is encoding it into model understandable format. Model is generating the output with the help of some of the hyperparameters, and then tokenizer is decoding it back, and then we are printing the response. Let me also put the print statement here, and now let me run it. And there you go. So model took a bit of a time to come back, but look at the response. So it says, sorry, let me just scroll down a little. Yeah, so now it is talking about it. It is understanding the problem, evaluating the expression without any parentheses. Very nice. And look how good it is. It is starting from the very scratch, that it is trying to evaluate expression without any parentheses. Very nice. And then it is talking about the order of multiplication. So the focus here is on how good the model is self-reflecting. It is correcting its own mistakes. It is checking the results, and then it is talking about different option. It is going on and on and on. So you see, it is talking with itself too, that maybe I'm close, maybe I'm not. I already have tried, and then wait, already did that in option one. Amazing stuff. So it is also sort of having a very short memory too, where it is using that to recall what it did earlier, and then it is going on and on and on. So really good stuff. So this is what I wanted to test, that it has this chain of thought. Okay, now let's try out another math question. This time I'm going to go with this differential equation. So let's see if it solves it. While it does, let's check out the VRAM consumption. So it is consuming around 64 GB of VRAM at the moment while it works. So that is, I believe, the peak. So make sure that you have that much VRAM if you are looking to run this model in full. Okay, so now we know what is the VRAM consumption. Let's wait for it to come back. Okay, so it has solved the differential equation. I'm not going to go into the mathematical detail, but if you look here, the steps looks really cool. And if you're a mathematician, please also guide us if you think that this chain of thought is looks reasonable. But I already have the answer from another model, so I'm just going to compare it, which is yx, yeah, looks good, is equal to 1 plus 2x. You know what? The answer is spot on. Really, really good stuff. So I think the model is very impressive when it comes to math. But let's try to pound it more. So now I'm asking it a topology question. So I'm asking it to prove that the Mobius strip is non-orientable. Let's see what it comes up. So it has given us the answer. Now, if you are like me and you don't know what Mobius strip is, this is Mobius strip, and I couldn't believe that I didn't know this is the name of this strip. Now, if you look at the question, so I'm asking it that prove that Mobius strip is not orientable. So it means that can we move it around, and can we always keep track of up and down in Mobius strip? So the correct answer is that it is not orientable. So if we cut it along the middle and follow the cut, we will end up back where we started, but on the other side of the strip. So this is why it is non-orientable. So if you look at here, it is saying that we need to understand what it means for a surface. Very nice. So it is trying to understand that surface. So it is defining the Mobius strip, and then it is getting some of the mathematics around that orientation, and then this is defining the vector field. It is traversing the Mobius strip, and then conclusion is, since a normal vector flips direction after traversing a closed path, it is impossible to define a consistent continuous normal vector field over the entire surface. So the Mobius strip is non-orientable. I think I need to take up out to this model. This is simply very fascinating to see that model has really done wonderfully well. Not only the answer is correct, but also if you look at the reasoning, especially how it has reached to the conclusion, this is not only fascinatingly, I would say scary. So I think very impressive. I should finish the video here, I believe. But anyway, let's move forward and check out more. There are various other questions I want to test out. Okay, next up I am asking it a probability question where a random variable x follows a normal distribution. So let's see if the answer it produces is correct or not. So if you look at the answer here again, I think chain of thought is superb, and this answer does not match with what I have. So but when it comes to probability, it could be anything, but I think this is a bit far off what I was expecting. But I will let you also do the calculation, then let me know. I have tried it out on two models. The answer on those two models, one is Llama 405, Llama 7, 3.370 billion, and OpenAI, both have given different answer. So please help me out here, check it out, let me know if this answer is right for this question. Okay, but anyway, let's try out another one. So this is just a graph theory. So let's see what it produces here. And it has come up with the answer. So if I quickly go through it, that is good. It is understanding the problem. And then it is, yes, that is correct. It is the number of edges must be an integer. And the final answer is this. Totally amazing. Spot on. Okay, so look, I believe the math is just out of this world. Let's try out a coding one. I'm just going to give it here this prompt where I am going to ask it to just give me a Node.js command line application which is going to do some directory and file management too. So let's see how it is in coding. And there you go. So it has gone in and it has given us, sorry, let me scroll down, and then you see that it is going again step by step, creating a directory, installing the packages, and then it is creating the application where it has given the constants, defining the functions. Very nice. Running the application, that's cool. And then it is explaining all the dependencies, all the components of that script. There you go, beautifully done. Amazing stuff. Okay, let's try out an Swift coding question where I'm just going to ask it to just create me a basic iOS app in Swift, and the app should have a simple interface to input an amount, select a currency to convert. So basically a Swift currency converter app. Let's see how it goes. Okay, so now here we have this basic iOS app where we are going step by step, that we are setting the Xcode project. Very nice. Design the user interface. I'm not, by the way, the developer, so please, if you're an iOS developer, please also advise us in the comments. And the steps look good to me. This is a UI kit. Good stuff. All the functions are there. And then it is also calling this exchange rate API. Good stuff. Look, I think looks really good to me. Very impressive coding skills. And normally if a model is good in maths, it is normally exceptional in coding. That is what I have found generally. And then finally, let's do maybe a Go question. So again, in this one, I'm just going to ask it to create a simple HTTP server in Go language with some of the routing. So there will be two paths there, greet and date time. So let's see what it does here. And there you go. So we have our Go stuff which you can check out. You can create a simple server. So what I really love about this model is that it understands the issue first and then it goes about it, and then it has given the complete code. And normally the what reasoning models also do in coding, I have seen that they go through a lot of iterations showing us. This model thinks, generates something, and then spews out the code immediately, which is really good. And then not only that, gives a very quick explanation, and then also tells us how to run it. Real good stuff. So that's it, guys. I hope that you are also appreciating the fact that this model has just been trained or fine-tuned using 450 US dollars, and look at the performance. I mean, we have come a long way, certainly. If you like the content, can you please do me a favor and share it among your network and subscribe to it? I would highly appreciate, because that's the only marketing I do. Thank you very much.